All right, so let's get started. And welcome everyone again. And today we'll be discussing about how we could upgrade or migrate a PostgreSQL or specifically a legacy or an older version PostgreSQL server to a newer version, and what are the methods that we could use to achieve that. And today with me here, we also have Jobin, Augustine, and Fernando, and also Nickolay. We're all the PostgreSQL experts who have done a lot of migrations or upgrades using any of the methods that you would see either in this webinar or a few other methods that we have not posted in this webinar too. So why is someone looking for an upgrade or a migrate to another Postgres with a newer version? The reason why somebody would look for upgrading their Postgres or any database software is specifically to ensure that they have all the latest features that they have with the latest releases. For example, see PostgreSQL 10 and 11, we got declarative partitioning, the native partitioning, and a lot of improvements in parallel query. And there are really great performance advantages or benefits that you see with the new releases. A lot of security fixes. At the same time, even when we are trying to do a benchmark of the performance between the older version Postgres and the newer version, we see that newer versions are really performing much better, right? So that is something that you expect with any database software too, most of the time. So that is why an upgrade is really important. And another key point is that the newer versions are supported by the community. When I say newer versions, currently starting from 9.4, the PostgreSQL version starting from 9.4 or higher than 9.4 are currently supported for any security fixes or bug fixes. And if you are on 9.3 or earlier versions, then any of the security or bug fixes that you get into are not supported by community. So community would not be releasing any patches to fix them, or no new versions will be released. So this is one of the reasons why someone would always wish to upgrade so that they always maintain a latest database version software. So the agenda for today would be, we'll be discussing about the upgrade checklist. What is it that you really need to look into when you know that you should be using a specific method to upgrade? And at the same time, we'll also be talking about 5 of the methods that we have, we could use around the PostgreSQL ecosystem to perform the upgrade. And we'll also see a demo of 3 of those methods, just in the interest of time. So what is a checklist? So when you know that there is a specific method that you could use to go ahead and proceed with a PostgreSQL upgrade, and you tested it, everything is working fine, you always ensure that you check if your hardware is fine before even proceeding with the upgrade. So what I mean by that is because your hardware may be overutilized or underutilized, right? So you either need to add more cores or memory, and depending on that, you change your Postgres parameters. So make sure that you use some kind of monitoring solutions, or maybe PMM. That's one of the Percona's open source monitoring and management product. So you could use such monitoring solutions to really see how your hardware is used. And based on that, you could plan your hardware specifications. And also the application to database connectivity. You may be using a connection pooler. You may be, you may have lots of application servers where you need to make changes in order to ensure that it connects to the new database server. If you are migrating a legacy Postgres to a new server and upgrading it, so you may even need to change your connection strings. So always ensure that you check the application to DB connectivity and make sure that everything is planned well ahead. High availability. If you are on 8.x or a few of the earlier PostgreSQL releases, even a few of the 9.x series, right? you may not be able to use the current high availability tools that are open source, of course, in order to set up automatic failover, which is transparent to the application. Or you may not be able to set up the best replication methods that are possible with the latest releases. So when you are upgrading your older version to a newer version, also plan your high availability cluster and test if the high availability solution that you're looking to implement works for the new version, and then see if it's all working good before even proceeding with the upgrade. And performance testing. This is one of the important things, like we need to ensure that we perform a good performance testing with a test environment. The reason is, with the new version, in order to get the real benefit of all the performance or the improvements that are done to the latest releases, you must also, sometimes you may need to code or recode, or maybe the way you used partitioning earlier could be different, and the way it is right now is totally different, right? So you may need to change some of your code to really get that performance benefit too. So test and check if you're getting that performance benefit, and then see if you have to make some modifications to the schema or to the application in order to really get the benefit of all the performance. Backup strategy. The older releases, or some of the 9.3 or earlier releases, or the older releases, do not have the the best backup solutions that are really available around PostgreSQL today. So for example, we have backup tools like PG Backrest, Barman, WallG. Those serve really different purposes, and at the same time, even PG based backup that is available with built-in Postgres, right? So in order to really use all these new tools, etc., you need to test whether your backup strategy really works, and then implement that before even you proceeding with the upgrade. There are many changes done to the PostgreSQL.conf parameters too, right? So plan all your PostgreSQL parameters in advance and see if there are any extensions that are missing or need to be created in the new version, and create them in advance so that you really do not get into any errors at a later point of time. All this should be known when you test it. So it's just a simple checklist. And now we will quickly jump on to the 5 methods and discuss them in detail. So the first method, and before I go through that, right, so we have some of the blog posts that are already published around these, and when you get these slides, it has got hyperlinks that connects you to those blog posts. You could always read them and post us any questions if you have. So we'll be discussing about PG dump all, PG dump with PG restore, logical replication, Slowney, and PG upgrade. So a concern will be downtime usually. So one of the major concerns why everybody are stuck with some of the releases is because of downtime. So among the 5 methods, there are 2 methods that could involve a huge downtime, and 3 of the methods that could really avoid a downtime, right? Or maybe very less downtime. So the first method, PG dump all. This is one of the utilities available with PostgreSQL source by default, and it's used to perform a text format dump of the whole database cluster. So you could just take a text format dump of the whole cluster that includes users, roles, or globals completely, and all the databases, and it dumps all that to a single text file. However, it cannot be done using parallel channels, right? Parallel processes. So it's just a single thread approach. And it may require double the space if you're taking a backup and again creating a new cluster and restoring that text file to that new cluster. So what you're doing in this step, or in this method, is taking a backup of an older version PostgreSQL, let's say 9.3 or 8.3, using PG dump all, and then restoring that dump file to the newer version. So this way, all the table bloat will be gone. However, it's a complete downtime for the business. So if you're okay to take downtime for writes, you can, of course, go with this approach because it's a single step approach and very easy. And next is PG dump and PG restore. And I did mention pgdumpall. The reason is that you cannot take globals backup, that is users or roles or table spaces, using pgdump. In order to take backup of the globals, you must use pgdumpall. So you first use pgdumpall to backup the users from the older version Postgres, and then restore it to the new version Postgres. So that way you go ahead and create your globals. And once you're done with that step, you then use pgdump and pgrestore. So pgdump is a utility available by default, or tool available by default with PostgreSQL source, the community PostgreSQL, and that helps you take a logical backup of a PostgreSQL database. And the advantage of using pgdump over pgdumpall for the upgrade is that pgdump and pgrestore can work using parallel threads. So for example, you have 12 cores or a lot of CPU cores, right? You could always use pgdump using multiple jobs. I mean, it can take maybe 4 or 8 parallel threads can be spawned, and or processes can be spawned to the database and take a backup. So the backup would be faster, and even the restore is very faster. So your upgrade will be more faster when compared to an upgrade with pgdump all only. And this method also removes the table bloat because you're recreating the whole database cluster. And it's just a logical dump. However, it involves downtime for business again, especially the write traffic. If your application is more read intensive, you could, of course, let the application connect to the older database server until the whole backup and restore is completed. But if it's write intensive and writes are considered a downtime, then you still have downtime involved with this approach too. So we have discussed about 2 of the methods so far, one with pgdumpall and another one with pgdump and pgrestore. And next, I would hand over the presentation to Jobin, who could talk about Slowney.
Yeah, welcome everyone. This is Jobin. So Avinash talked about the logical restore, backup and restore methods, and that involves downtime. So now we are going to see a couple of scenarios where we can avoid the downtime. So the Slowney replication is one of the oldest in this area. And it is not only for the migrations or upgrades, it is a general purpose replication. It is used across data centers, especially when we deal with the Postgres versions before 9, and it is more than a decade old in terms of maturity, and is widely used. And the main point here is it's a logical replication. You all know that the Postgres has binary replication built in, and recently it came up with the logical replication features. But Slowney does the logical replication, and it has the publisher subscriber model for doing that. And one of the requirement for any logical replication is that every table need to have the primary key. And I think the same holds good for all databases and all types of replication. And this Slowney is a trigger-based replication. So when a database change happens, the data will get recorded in another Slowney log. It is basically a trigger get fired and the log will be generated. And the advantage of Slowney is that you can do this replication from very old versions, even unsupported versions like 8.4 till Postgres 11, the latest currently, which is in production. Yeah, and since it's a logical replication, you can use it for both upgrades or even downgrades. Suppose you have your application which is not tested for a latest version, and you went ahead and later you want to go back to a previous version. Yeah, this is the option. And but there are a few limitations. Say the DDLs are not really supported for replication, but there are ways through which it can be handled. And the blobs is another area of concern. Yeah, so but there are ways to handle that. but we won't be covering that in this presentation. And once we done this, the slave completely synced with the master, we can just switch the application to the slave. The slave is going to be the subscriber node. Okay, next slide. And as I mentioned, the Sloaney is of more than a decade old. So, hello.
We can still hear you. We can still hear you, Jobin.
Yeah. So since the Sloaney is more than a decade old, there is a lot of features. The ecosystem built around that is very versatile. So there are monitoring tools, scripts, and the replication health check scripts that comes with the Sloaney. So when you do the Sloaney replication, you have complete set of features to assist you, and there are fully automated solutions available, which will even prepare scripts for you. So like Altupal is one of the tool which will prepare scripts, and the Sloaney can do the replication in. You can set it up in multiple sets and merge the sets later on. So these are some of the features you may really use when you deal with a very complex replication scenario. Okay, so you just need to keep in mind that it has a lot of features because it is pretty old, yeah, and matured. Yeah, next slide. And when it comes to migration scenarios, there are two cases. One is you already have a very old system where there is a replication chain built using kind of Sloaney, and the other scenario is you are moving completely from a single node to another single node new version, where you don't really care about the currently existing replication chain. So if you have a existing replication chain, the Sloaney has features to transfer that ownership of replication from one node to another node. So if you are stuck up because of you don't know how to do that, this is the way you should approach. Basically, it is you are going to log the entire replication. Basically, it will prevent the client updates for temporarily, and move the replication from your existing database to a newer version. So you can actually move the ownership, the replication ownership from one node to another. And this is useful if you want to preserve the replication chain. And if you don't have to do that, it's very simple. You can just execute unsubscribe the replication set, unsubscribe set, and specify the parameters. It is very simple to do. Yeah. So shall we look at a demo?
Yep. So let me go ahead and get the terminals up. So now what we'll be looking at is how, Jobin would be explaining more about some of the files as well as some of the scripts and how he has set up replication from 8.4 to 11. So we'll quickly see that in action. Okay. So now I'm going to demo you. Yeah, so I would let you talk, Jobin.
Yeah. So currently you are seeing a machine, a PG Sloaney 8.4. This machine is having Postgres 8.4 version running, and we are the prerequisites are already installed, but we are going to set up the replication right in front of you. So, and we have one more machine, PG Sloaney 11, which is where the Postgres 11 is running. Yeah. So currently there is nothing. Yeah, yeah. So let us start. So we the entire demonstration is coded in a shell script. So let us proceed. Yeah. So as I mentioned earlier, for any logical replication, the primary requirement is that all the tables need to have a primary key. So we must ensure that there is a primary key. Okay. So here we are taking a pg dump and checking the create table statements, how many are there, and how many of them got the primary keys. So we can see that all the tables are having primary key. This is one of the basic requirement. Yeah. And now we can copy the schema from 8.4 to 11. Okay, so basically here we can see we are executing a pg dump on the 8.4 and piping that to the PSQL running on connected to the Postgres 11. So the schema dump, the table definitions and sequence, everything will be dumped to the other side. So yeah, so now we are proceeding to the Slowney configuration. Now we have two databases with the same kind of schema, but not the data. Okay, so the Slowney configuration, we are seeing the init script. This is the initialization of the cluster, and we should remember that everything in Slowney need to have a number identity. Say the node has a number, the table has a number, and the replication set also has a number. So the primary we are putting a number called 1 and slave is 10. So here basically we are giving all the connection string information, and we can see a line called init cluster, and that is going to initialize the master node with all the replication information and even the schema. So when we execute this, it will be creating the metadata about the master and the slave, and it will connect to the slave because we already have the slave information specified. It will connect to the slave, and there also it will keep the connection information. So now we completed the execution of that script, and let's see. So now here we can see we have underscore Slowney schema created, because this is Slowney is the cluster name we specified in the script. So any cluster name you specify will appear as an underscore and cluster name. So this schema contains all the Slowney related metadata. Now we have both the nodes ready with the metadata. Now both the nodes need to talk to each other. So we need to have a daemon for that. So the Slown is the daemon, and we are going to start it up. So there is the configuration file tells how to connect to the other node. That's it. So we are starting up the daemons on both the nodes. Now let's see how we can do a replication of table. So a small table T1, so that it will be very clear for you. So this is the subscription script for that. We are specifying the node information, and we can see that there is a statement called create set, and it creates a replication set. There we are specifying what is the primary, and following line says we are set add table. We are adding a table to that set, and there we can see that it is the table name is public.t1. So a table called t1 in public schema we are adding to that set, and following line says subscribe that set in the slave side. So the subscription is we need to specify who is the provider and who is going to receive that changes. So once we execute this, the table in T1, table T1 on the master will get replicated to the slave. So currently we can see there is a table T1 is getting replicated to the slave. Yeah. So now the initial information is getting replicated. Now let's try doing some DML operation. So in the master. Okay. So we inserted some record. Say insert into T1 value 3, and it got inserted into the master node. Let's see whether it is replicating into the slave node. Yeah, it's coming in the slave node. Yeah, So in the script, we purposely kept a small delay so that the replication sometimes takes little time because the synchronization happens in every seconds. Yeah. And the next script, we are going to add a lot more tables to the same subscription, the replication set. We all sysbench related tables like PG account, the bench accounts and PG bench related uh, 4 tables. Here, one important thing you may have to notice is every table has an ID. So the first set of script, we kept a ID 1. Here we are going to use ID 2, 3, 4, and 5. And before adding the table, we are unsubscribing, and after adding the table, we are subscribing it again. That's what we are doing in the script. Okay, so let's proceed. So now the entire tables are replicated, and shall we check in the Postgres 11? /dt plus. Yeah, so all the tables came with the data replicated. Okay, so once both the old database and the new database is perfectly in sync, we can just execute the unsubscribe. So the last script which is on the screen is all about unsubscribing. So once the replication is unsubscribed from the new database, the replication is no longer coming into that, and it is independent of the previous replication set, and application can be redirected to the new database. Okay, once you have done everything, better to clean it up. There are a lot of cleaning scripts available. Or basically, we saw what is subscription and what is set and what is node. So here we are going to, as you can see, we are dropping the set and we are going to drop the node definition. So all the metadata related to Sloane replication will be wiped off from both master and slave. So the new server will be independent, and the application will be ready to connect. And of course, once you do all this migration, always remember to analyze the tables, because we are moving to a new machine. Yeah. And yeah, so remember, we done a daemon in the backend. So please remember to kill that as well. Yeah. Okay, and so we saw the historical way of doing replication using Sloane, and from Postgres 9.4 onwards, we have the logical decoding built into the Postgres. So the logical replication feature using PG logical is using that logical decoding feature, and this also uses the publisher and subscriber model, because it's all we can see a lot of similarities between them, but this works entirely different way. Okay, and the major challenge is the built-in replication works from Postgres 10 onwards only, because without this PG logical extension. But as I mentioned, the logical decoding came in 9.4, so this extension can help you to get that replication done. So this is a matter of just installing that extension. And like any other logical replication, one of the primary requirement is that every table need to have a primary key. And once the new slave catches up with the replication, it's a matter of starting the application. And any logical replication migration involves very little downtime, because it's just matter of switching the application to a new database once everything is caught up. Okay, so let's have a quick demo of logical replication. So this is PG Logical 9.4. Here Postgres 9.4 is running, and we have one more server where we have Postgres 11 is running. So let's try to replicate between them. So imagine that our application schema is sitting on Postgres 9.4. So first of all, connect to our database. So say the Percona 9.4 is our database, and see what are the extensions currently I installed. So we can see there is a PG Logical extension and a PG Logical Origin extension. So in 9.4 we need to explicitly create this extension, the PG Logical Origin. In newer versions, when you create PG Logical, automatically that brings the functionality into this. Here also we may see the extension, but you don't have to explicitly install it. Yeah. Okay. And the thing is, when we create a logical replication, we need to define the nodes. There is a publishing and subscription model. So this is the older version server become a publisher. So it's a we are going to call it provider node. So we are going to define a node definition in this node. So we have to do the same thing on the other side as well. There it will be a subscription. It's a subscriber. So basically it tells PG Logical how to connect locally to its own database through extension. Yeah, so we defined both provider and the subscriber. Okay, now let's add the tables. So this is a very simple method. As you can see, it tells set add all tables to a set. So the default is the set name. So you can put any name you want. So we are calling it our set as default, and array of all the tables. So in public schema. So every table in the public schema will be added to this this replication set here. So let's see the metadata. So metadata is the node related information is stored in yes, like we can see the provider node is there, and all the tables are added to that the replication set. Now the master node is ready to publish all the changes happening in this tables. Let us move to the slave side, the subscription side, and enable the subscription. Yes, now we are doing a subscription. One important thing here you may have to notice is the last parameters, synchronized structure is true. You remember when I demoed the Sloaney, we took a logical backup and restored into the new server. But the logical replication using logical PG Logical is capable of bringing those schema definition also to this node. So let's see whether all the tables came now. Yeah. So all the tables are created and all the data is getting replicated. Okay. So now, yeah. So now let's see how to add a new table to this replication. So we are creating a table, and we are going to create the same table in the other side. So, and we are trying to add this table to the same replication set. So let us add the. So this will add the table to the replication set, because since the replication set is already existing, all the changes happening in this table also should get replicated. So let's add some data here. Yeah, and see whether that data got replicated there. Yes. So it's very simple. Create a define two nodes, both provider and subscriber, and add the tables to the replication set and enable the subscription. Very simple, very straightforward. Yeah, and in future this is going to be the standard, the logical replication. Yeah, and there are a lot of advantages with the logical replication compared to the old way of doing. The major difference is this don't have any triggers. So the logical information is getting recorded into vals and propagating to the subscription side. So there is no concept of triggers anymore. And there is no SQL execution. So you may be knowing in other databases the statement replication. So here actually there is no statement replication, and it is doing a logical decoding. So there is no SQL statement getting executed on the slave side. It's very lightweight and simple. And say the subscriber node can be it's open for connection. So suppose you are migrating few of the schema, the subscriber node can have other database running as well. So it is not in hot standby mode. It's not in standby mode. It is open. Yeah, and another advantage of all this logical replication is like no need to cancel any queries to because in physical replication there could be some queries get cancelled because of the vacuum in the primary side. So here two databases are independent, only logical data get replicated, so database can be independent. Yeah. Yeah, so I think we covered.
Yeah,
that.
thank you, Jobin. So I would let Fernando now talk about our fifth method, which is using PG upgrade. So far we have seen 4 methods using which we can upgrade a older version PostgreSQL. Now all over to you, Fernando.
Okay, thank you, Avi. So let's have a look at this last approach. So PG upgrade is a built-in tool that comes into Postgres, and it provides a different way, a different approach for this in-place major version upgrades of Postgres, right? The point it kind of explores is the fact, the consideration that when it comes to the data structures where Postgres is built upon, the system tables are the ones that will undergo most of the changes from one major version to another. While the internal tables, the user data per se, it will rarely see a change in its format, and that is kind of on purpose. So they try to avoid this. So the approach that PG upgrade uses is, in fact, to kind of rebuild, or so to speak, the system tables from the upgraded version of Postgres, and keep the user data kind of intact, which simplifies a lot the upgrade process, and may as well help in minimizing downtime. We'll get to that. So it works like this. You have a Postgres server running an older version, and you just install the new binaries from the new version you want to go to, and you actually deploy a new cluster using those binaries, right? A clean installation. So the first step is to actually run PG upgrade in a check mode, just to verify the compatibility between this new setup and the current server that is running, right? So it not only checks for major settings, but also for the availability of any extension that is being used, main user accounts, and so on, right? If there is any problem, there is diagnostic during this initial point, the check will fail, but you have the chance to fix that in the new server, right? In the one that you are preparing to migrate to. And the second step, which is the actual migration, so to speak, it's where the approach can take two completely different directions depending on your needs, and which is what this slide we are seeing here is about, right? To employ or not to employ hard links. So a hard link proceeds, we're talking about a Linux hard link. So we just discussed that the system tables, they change. So when we build a new version, a new cluster from a new version, we are deploying new system tables. And the objective here is to keep the data from the user data almost intact. So when you are not using hard links for this, the data will actually be copied over, right? It's not like a simple OS copy. It's more complex than this, but we are actually having a duplicated copy of the data in that server. So you need to have at least double the disk space available to replicate that data, right? And the biggest advantage on this is that you will be starting from scratch with those user data, so that it actually removes the bloat from the tables, and you could have a data directory that is in a different file system than the main one from the previous or the current server, right? Problem is, this is very time consuming. It's very similar to doing a PG dump and a PG restore, even though it's faster, but still very time consuming. And the point with an approach like this is really to make it not only more practical, but to limitate downtime as best as possible. So it really makes sense to use this approach mostly when you opt into to make use to employ hard links. So the condition for this to work is that you need to have to keep the data directory for the new server, for the migrated server in the same file system. So hard links they only work on the same file system, right? As a disadvantage of this approach, so you are kind of switching the time for not getting a more optimized table. You are not starting from scratch with the tables. You are just taking over the user data tables from the previous server to this new one, right? The biggest advantage, once more, is the fact that the downtime is really short. So let's have a quick look at how this looked like. Avi, can you switch to the terminal, please?
Sure, Fernando. So I would quickly go ahead and switch to the terminal and let Fernando present. Yes.
Okay, let's see. Oh, we have you here. All right. So in this server, we are talking about a major version upgrade on the same server, right? So we are just going to use one server. And in this server, you see there is a Postgres running on version 9.4. So if you just have a look at it really quickly, we see there is almost 7.5 gigabytes of data already in there in this main Postgres database, right? And we can also confirm that with a quick look at the file system usage space, 8.5 gigabytes. So the point here is we need to deploy a new version of the Postgres we want to go. So to use. So I already have the binaries installed here for the Postgres 11, which is what we are going to use, right? So I will just deploy a new cluster very quickly, like this, right? What we need to do, remember, we need to change the port because we already have a one Postgres running on the default port. So we will just go in the configuration file and change really quickly it to run on port 5433. And now we can start the server, right? It's there. So if we look again at the process running, we see there are two servers now. There is the Postgres 11 on /varlib PostgreSQL 11, and we have the legacy var at varlib PostgreSQL 9.4, right? And we connect to this server and we check the Postgres database is kind of empty, right? It's a fresh new one. So we stop this new server. It needs to be stopped for the check to take place. So let's just stop it really quickly. And let's run PG upgrade the first time, like we discussed it previously. So here's the command. It's a long one, but it's actually simple to understand. We are using the binary, the PG upgrade binary from the latest servers from Postgres 11. And the -b here denotes where the binaries are for the legacy server. And the uppercase B, it's denoting where the binaries are for this new server, right? Likewise, the lowercase d denotes the data directory from the legacy server, and the uppercase D denotes the data directory from the new Postgres version. And we are using the option --check, --check here to just do the check, the compatibility check, right? So here it all went well. If there was any problem, it would be mentioned here. When I did the first check, I have used a different locale for my new server. So it failed right here, and it pointed me to that fact. So I just started it again with the right one. So here we saw that the check is all right. We don't need to change. We don't need to adjust anything. So what we are going to do now is to stop the legacy server. Both of them need to be not running when we do the final execution of PG upgrade, which is almost exactly the same command as before, but instead of the option check, we are using the option link. Here we are creating hard links instead of duplicating the data, right? So what is the problem?
Oh yeah, there is you put a v9.4.
Oh, let me just do that again, just to not. Is it right now?
No,
I don't.
Yeah, v9.4, is that right? It should be 9.4 in the data directory minus lowercase d data directory. Yeah, there is an extra v beside 9.4.
Oh, I don't know that where it comes from. Okay, thank you, Avi. So we do that final step, and it creates the hard links. Note that it also pointed to the upgrade is complete, but it also pointed to two extra scripts. The first one, it's this analyze new cluster here, which is actually going to do a vacuum on all databases, right, on the new server. And the second script is a delete old cluster, because we can't just delete those files in the old directory if we want to, right? And then again, the final step is just to start the new version of Postgres running on 11, right? And again, if we check for disk space, we will see the same amount of disk is being used. And if we go again and connect to this new server, we see it is using the same. Now it grow to the same amount of the legacy server, right? So pretty fast, pretty sweet, and that's it.
Thank you, Fernando. So this really great approach, like we were able to use a similar approach on one of our customers' environment where they have created a 3.5 terabytes database cluster in less than a minute, just using the hard links option. So as Fernando mentioned, we need to make sure that it's on the same file system. I mean, if you would like to migrate and upgrade it to a new server or create a new cluster on the different file system, it would not work. So thank you, Fernando, and thank you, Jobin. So all over to the questions. So I think we can take a few questions. Maybe we'll just see the questions that you posted, and then yeah, we'll try to answer them.
Great. All right. At this time, go ahead and enter your questions down in the questions panel. As a friendly reminder, today's recording will be sent to you along with the slides. So our first question is, hi team, thanks for this webinar. Does Percona have an enterprise version of Postgres or supporting only open source versions of Postgres?
So,
Shall
okay.
I?
Yeah, go ahead, Jobin.
Yeah, so unlike many of the open core projects, the Postgres don't have multiple versions. So it's an open source community project. So there is no feature you are lacking in community version. So there is no personal edition or community edition or enterprise edition separately. So Postgres is a single source tree, and you're getting all the features in community edition, or there is only one version. Yeah. And since it's an open source community, all these tools, including Sloany and everything, is a separate project. It's we call umbrella project, Postgres related projects, and they have their own community as well. So these are independent communities, and they contribute back to the Postgres development. For example, PG Logical, it is mainly developed by a company, and they contributed their ideas back to the Postgres core, and including the logical decoding. And now that is there in Postgres. And in addition to that, any new feature in Postgres comes as an extension. We already saw the PG Logical extension. So Postgres is open for extending its features through extensions. We can accept any extension, including, say, for example, you want to write stored procedures in JavaScript, which is not there in by default. But once we add PG PL V8 extension, you can do the same. Yeah, you can write stored procedures in JavaScript, or there are extensions for Perl, Python, etc., etc. So pretty much you can write in any language of your choice. So the key point I want to say is there is only one version of Postgres. Yeah.
And all the versions or all the tools that we have discussed today, you do not have to pay or subscribe to any other enterprise versions to use them. So if we have not mentioned that in the slides, like all these tools are available for free, anybody could use it. There is no need of any enterprise subscription, in fact, and that's a really great question. Thank you.
Thank you. Our next question is, are there any reasons to use Sloany instead of PG Logical when migrating from 10 to 11?
Yeah, that's a good question. From 10 to 11, we have built-in replication. So you may try that first, even before PG Logical. Yeah, so the second option could be PG Logical. And there is no real good reason why we should use Sloany in a newer version, because we have a lot more features in newer versions. Yeah.
And it's an additional overhead too because of the
Yeah,
triggers.
correct. And some of the synthetic benchmarks shows the trigger-based replication in many times 5 times lower than this built-in logical replication. Yeah, so because of the trigger overhead, which Avinash just mentioned. Yeah. So select the migration strategy based on your environment. Yeah.
Great, thank you. Our next question is, are there GUIs for these tools?
That's a really good question, interesting question. I mean, as we have actually seen in the demo today, we were able to present like 3 solutions just within a very few minutes of time. So it's how simple it is to just deploy, the commands on the fly. And like, for example, logical replication, Jobin could just do it in like 4 or 5 steps. Likewise, Sloaney, right? So we do not have GUIs or like it's always something that we could just using the commands, simple commands that are available, but we really do not have any reason for GUIs to be available for this. So I don't think, yeah, the answer is no, but it's very simple without the GUI.
Thank you for that. Our next question is, can we use EDB?
You mean these tools on top of EDB, Postgres? The answer could be, I mean, so far as I've seen in some discussions, like there are some of the tools, like specifically Sloaney, that I doubt that you could do it on an EDB Postgres. But however, I've not tested it myself. You really need to test that, or maybe EDB could really give more detail into that, like what works with EDB Postgres and what does not. Yeah, but few may not, like what we discussed today. Like most of them could work, but we really need to check more with EDB, or like if you're using their own Postgres fork.
Thank you. Our next question is, how would you upgrade Postgres on an AWS environment?
I think AWS, it depends on if you're using an RDS or a RDS, or if it's deployed on an EC2. So if it's on an EC2, of course, or a virtual machine, like you could just follow the procedure that we discussed today. And if it's an RDS, I think just through the GUI, like you have options to just click and upgrade your database versions. It's pretty straightforward. There are many documents available where like RDS, of course, or Amazon AWS, of course, lets you create only the currently supported PostgreSQL versions, and you could just with single clicks, like you could just proceed and upgrade if it's an RDS or an Aurora.
Thank you. Our next question is, what about a Barcardo solution? Any thoughts on that?
Yeah, so that's something that I've used personally some time back when there was an 8.2 PostgreSQL that needs to be upgraded to a 9.5. It was 3 years ago. So, but we need to remember a point that it's not currently supported, and at the same time, I mean, we have currently demonstrated all the methods that are well tested, or something that really works with the current PostgreSQL ecosystem or the versions. Barcardo is something that you may try, but there are a lot of code changes, etc., needed to let it work with 10 or 11. The answer to your question is currently it's not supported, and so that's why you may prefer Sloaney.
Thank you. Our next question is, on PG upgrade, what do we need for the replication setup when we perform an upgrade on a master or primary?
So when you say what do we need, so as Fernando mentioned, like we need to just have the Postgres new version installed. That's the first step. And the second thing is to make sure that you have enough disk space if you're not using hard links, or if you're using hard links, then the immediate next step is to check if you have all the extensions and the tools that you've used around your older PostgreSQL version also installed for the latest, right? So for example, you got an extension called PG Repack, which is for 9.4 version. You also need to have the PG Repack installed for Postgres 11, else your consistency check that Fernando has performed, right, it fails. So when you perform a consistency check and you see that it fails, right? Whatever you see over there as failed is what you really need to do before the upgrade. At the same time, you also need to make sure that you have all the parameters in your new PostgreSQL.conf set according to that version. So I think apart from this, I don't think you really need to do anything.
Thank you. We are at the top of the hour. And so what I'll do is I'll collect everybody's questions that we couldn't answer today. I'll make sure to pass those on to the presenters, and then we'll do a follow-up blog post from there. But go ahead and continue to send in your questions, and I'll make sure to kind of log those. And then also, as a reminder, the recording will be sent to you as well as the slides. All right, so I've recorded everybody's questions. Thank you so much, everybody, for attending today's webinar. Huge thanks to the team. Thank you so much for presenting the webinar today, and we hope to see you on future webinars.
Thank you, Emily.
Thank you, everyone.
Thank you.
Thank you.